Hello! In this video I want to talk about a method that we can use to symbolize more complex all, every, some, none sentences. It's called the quantifier phrase verb phrase method, and it involves a grammatical analysis of sentences that use those quantifier words and how to break them apart into their pieces and see how their pieces correspond. The pieces of the English sentences correspond to the pieces of their symbolizations in the logical language, even though and we'll see that's a somewhat complex correspondence. So we're going to first see how that correspondence works with some sentences that we're familiar with, and then we're going to use this method to symbolize more complex sentences. So let's take a look at some relatively simple sentences of English that involve quantifiers and how they're symbolized, and see what the similarities and differences are between the sentences of English in this case and the sentences of the logical language. So let's note first, if we just look at these two sentences of English, Alice chirps and every emu chirps, that at the top level, they have the same structure. They both break into a noun phrase, in the one case, Alice. The Alice chirps breaks into two parts. There's the noun phrase Alice and the verb phrase chirps. And every emu breaks in the same way. It has every emu as one part and chirps as the other part. Every emu then breaks into two parts, every and emu, but at the top they have the same structure, two parts, a noun and a verb, and then in the case of the quantified sentence, then that noun phrase, and what's actually a quantifier phrase, every emu, breaks up. We now want to take a look at the symbolizations of these two sentences. So Alice chirps would just be like CA, and every emu chirps, that's universal. If you're an emu, then you chirp. If EX, then CX. No problem. Let's look at the trees for our two symbolizations. So CA, that would just break into A and C. For all X, if EX, then CX, right? And so that's actually CA, that's like the tree of Alice chirps. It's got two parts. And then it's done. For all X, if EX, then CX, we take off the universal quantifier and we have the conditional, and then the conditional splits into two formulas, EX and CX, and those break up. So we can see that symbolization, or the tree, of this universal is quite different than the tree of the CA, and in particular they're different at the very first step. CA breaks into A and C, whereas for all X, if EX and CX breaks into the conditional. We just lop off the quantifier and we still have the conditional with two pieces. And so those are then very different trees, these two trees, quite different. And then if we compare every emu chirps, the tree of that in English, to the tree of for all X, if EX, and CX, again, we can see that those trees are very differently shaped, and in particular, they're very different at the top. In the English language, it splits, the two pieces are every emu and chirps. And so the top sentence has two parts, that every emu and chirps, then we split up every emu, but the key thing is that the sentence has two parts. Whereas the symbolization in English has one part. It's the universal, and then we take the universal, which is attached to what? The conditional. So the universal is attached to a conditional. It's got one part, and the part is a sentence. So the English sentence splits into two things that are not sentences, whereas the universal has the universal symbolization has just one thing, which is itself a complex sentence. So that's really, really different. English, two pieces, neither of which are sentences. The universal in the logical language has one piece, which is itself a conditional containing two formulas. So those are quite different. And that's the fundamental reason why symbolization with predicate logic is difficult. It's because quantifiers in English, every emu, and quantifiers in the natural language for all X actually work quite differently. We can compare them. So natural language quantifiers, like every emu, where does that go? It goes where a name goes. It goes where Alice goes. Whereas a logical language quantifier goes where negations go. And where do negations go? They go on formulas. So natural language quantifier goes where a name goes, and that means it attaches to a verb, like chirps. Whereas a logical language quantifier, like for all values of X, that attaches to a formula. So they go in different positions, and they attach to different things. The natural language quantifiers, every emu, some emu, and logical language quantifiers for all values of X, for some values of X. And so we see that they have these different trees. The last thing we want to point out is that natural language quantifiers are restricted. What does that mean? So everything is a mammal, that's unrestricted. It talks about everything, and it applies being a mammal to all of them. So it's unrestricted. That everything talks about every being. But that's a fairly rare natural language quantifier. What we more typically see is something like every whale is a mammal. And there the every is attached to a whale. So in these two sentences, everything is a mammal and every whale is a mammal. In both of them we have the word every and we have the word mammal. But they work differently because everything is a mammal applies mammalhood to absolutely everything, whereas every whale is a mammal, it has a restricted scope. It applies whalehood only to, mammalhood only to every member of the group whale. So it's restricted because it's about only the whales. And so it's weaker, right, than everything is a mammal. It doesn't say as much. On the other hand, logical quantifiers are entirely unrestricted. So for all x fx, that talks about everything, and it says all of them are f. For all x, fx, and gx, again, talks about everything and says they're all f and g. Some x, fx is also unrestricted. It says among the group of everything, at least one thing is f. And some x, fx, and gx says, again, among the group of all things, at least one is both f and g. So both the universal and the existential talk about all things. They say different things about the group of all things. The universal says, in that group of all things, all of them are a certain way, whereas the existential says, among the group of all things, at least one of them is a certain way, but they both are about everything. So we have the two grammatical differences. Natural language quantifiers go where names go, whereas logical quantifiers go where negations go. And so natural language quantifiers attach to verbs, logical language quantifiers attach to formulas, and then natural language quantifiers normally are restricted to a group of objects, the whales, the emus, the mammals, the people, the rocks, whatever. Logical language quantifiers are always unrestricted and talk about absolutely everything. And so those are a bunch of differences that are what produce the hurdles we have to get over when we're symbolizing, when we're taking natural language quantifier sentences and turning them into logical language quantifier sentences. But while they're different, we can still have a systematic method for turning sentences of English and other natural languages into sentences of the logical language that looks at the grammar of the English sentence or the other natural language sentences and says, we're going to turn each of the pieces of the natural language sentence into part of the logical language. It's just a little complex how that happens, how that transformation happens. So let's look at every emu chirps. What are the parts of it? It's got the chirps, which is a verb phrase, and it could be bigger. It could be chirps loudly, or chirps and eats, or chirps and flies, but in this case we just have the simple verb chirps. And that's what we're going to say about the subject of the other part. We're saying chirps applies to some entities. Which entities? Well, that's what the quantifier phrase tells us about. It's what we're talking about. So it's a quantifier phrase because it's a phrase formed by taking a quantifier, a quantity word, a quantifier word is a quantity word, and attaching a noun to it. Right? There are two parts to a quantifier phrase. There's the word every, which is a quantifier, a quantity word, and then there's the noun, in this case, just a simple noun, emu. And so what's going on is we're talking about the emus, and that's the group of things, and we're applying the verb chirps to them. And which ones are we saying chirps? All of them. So each of these words has a different role. The emu word picks out the group. We're going to apply the verb phrase to the group, but to which members of the group, and the quantity word tells us, in this case, to all of them. And then that's what the sentence does. So given that the sentence has these parts, it has the quantity word, the noun phrase, and the verb phrase, each of those parts of the English sentence end up in specific parts of the logical sentence. The word every gives us the universal quantifier, but because it's hooked up with the noun phrase, it does other stuff. It gives us a conditional, and it gives us two x variables. The emu turns into the e, and the chirps turns into the c. So if we look at the tree, we can see where what that word every does is it's going, again, to the universal and the conditional and the two x's. The emu gives us the e in the antecedent, and the chirps gives us the c in the consequent. And so while we don't have a one-to-one correspondence, every emu chirps and this universal conditional have different trees, there's a correspondence between the parts of the English tree and the parts of the logical tree, and this is what they are. The every gives you the stuff outlined in purple, the emu gives you the that sort of aqua thing, and the chirps gives you that yellow-green part. And it's general. It's not just for emus. The quantity word, the universal quantifier, right, is giving us those, but it's the noun in the quantifier phrase, which is emu, is always going to go in the antecedent, and then the verb phrase is always symbolized in the consequent. So just like with every kiwi flies, or every emu chirps, so with some kiwi flies, there's also correspondence between the three pieces of this: the quantity word, the noun that the quantity word attaches to in the verb phrase, the verb, and the symbolization. So the quantity word some gives us the existential y at the beginning, but it also gives us the conjunction and those two y's. And then the noun that the quantity word attaches to, in this case kiwi, gives us the k, and the verb flies gives us the f. And it's, again, so the quantity word is giving us both a quantifier, in this case the sum, and the propositional connective and the conjunction. The noun that the quantity word is attached to, that's kiwi, gives us the k, and the verb left over gives us the f. And it doesn't matter that it was kiwi or flies. If it had been whatever the noun, if it was, some alligator is dangerous, then we would be symbolizing alligator in the left conjunct, because it's the noun that attaches to the quantity word, and is dangerous, we get symbolized in the right, where the verb part gets symbolized. So we have a general method here. We say, let's find the quantifier phrase, which is the quantity word and some noun, and the verb part, and split them, and that sort of gives the initial splitting of the English sentence. And then within the quantifier phrase, where we see there's a quantity word, all, each, every, some, none, only, and a noun that it attaches to: bird, happy bird, big bird, large emu, whatever it might be. And then the quantity word, no, every, some, or whatever, gives us both a quantifier and a connective, so either universal or a conditional, and then if a universal, also a conditional, if an existential, also a conjunction, and then if it's no, we have a negation at the front of the existential. So we put those the logical symbols in, the quantifier, and if we need one, the negation, before the quantifier, and then the conjunction or the conditional. And then we symbolize what's left over, and what's left over is the noun from the quantifier phrase and the verb phrase. And so then we just stick the noun and the noun phrase from the quantifier phrase on the one hand, and the verb phrase on the other, wherever they go. And that's a general method for symbolizing natural language sentences with quantifiers. That's not the whole method, but we can go a really long way with this method. And in particular, we can use this approach to symbolize more complex sentences. And I'm going to show how to do that, how to use this method in the next video, and I'm going to show how to use the method with more complex sentences. So let's go take a look at that.